Hi, today I will explain about what is mesomeric effect and mesomeric effect. This is the definition of mesomeric effect. What is the definition of mesomeric effect? And what is the definition? Pi electron delocalization in the conjugated system is called mesomeric effect, and pi electron delocalization or displacement in the conjugated system is called a mesomeric effect. This is the definition of mesomeric effect. First of all, we have to know about what is conjugated system, and then here the conjugated system definition. What is the conjugated system? The molecule should have sigma and pi bonds at alternate positions are called a conjugated system. That means the molecule must have sigma and pi bonds at alternative position, and those compounds are known as conjugated systems. And here some examples I am given. Here what is the example? This is one of the example. Here the 1,3-butadiene, and here pi bond and sigma bond, pi bond. There are two pi bonds are exist in this molecule, and here the one pi bond, this is the second pi bond, and these two are alternatively existed with sigma bond. This is pi bond, sigma bond, pi bond. Actually total 4 pi electrons are exist. Why? Because 2 pi bonds and then 4 pi electrons is exist in the system. And then here how many pi bonds are there? Here 3 pi bonds are exist and the 6 pi electrons are exist. Why? Because each bond can make 2 electrons. Each bond will be formed by using 2 electrons, and then the 3 pi bonds will be conjugation, involves in conjugation. How? This is the pi bond and the sigma bond, and the pi bond, sigma bond, pi bond, sigma bond alternatively exist, then it is a conjugated system. Here also conjugated system, one pi bond, sigma bond, pi bond, conjugation system. And here also 4 pi electrons are exist. Why? Because 4 pi bonds are exist. In this case here also conjugated system. How? Means pi bond, sigma bond, pi bond, sigma bond, pi electrons, 2 pi electrons are exist. Actually here the how many pi electrons are exist means there are 6 pi electrons are exist in this system. How? Means here the pi bond 2 electrons, here the pi bond 2 electrons, and this non-bonding pair of electron, I mean lone pair of electron also involves in conjugation. Conjugation means alternative sigma and pi bonds, and not only sigma and pi bond. In some cases, in some molecules, the lone pair of electron also involves in conjugation with pi bonds. Here we can observe pi bond, sigma bond, pi bond, sigma bond. Instead of pi bond, one lone pair of electron will be exist, and this is the one of the conjugated system. I mean simply in conjugation, sigma and pi electrons, pi bonds are arranged alternatively. In some molecule, lone pair of electrons also involves in conjugation with pi and sigma bonds. These are the conjugated system, and we can decide it, and we can explain what is mesomeric effect now. And this is the conjugated system. Compulsory one rule: mesomeric effect will be observed in conjugated system. Okay, and then what is pi electron delocalization? Just we can observe, we can take in one example, 1,3-butadiene. This is 1,3-butadiene. In that case of 1,3-butadiene, there are 2 pi bonds are there, and we can writing here one pi bond will be migrated in this direction. I mean this pi bond can make a bond in between these two carbon atoms. That means this is one first carbon atom, this is second carbon atom, this is third carbon atom, this is fourth carbon atom. The pi bond exists in between 1 and 2 carbon atom is migrated in between second and third at the same time, and the 3,4 bond will be migrated towards carbon atom, and it will be forms a resonating structure like this. Here the pi bond is exist, and this first carbon atom loss of pi bond, then positive charge, and fourth carbon atom gaining of pi electrons and the negative charge. And this is the pi electron delocalization, and this effect is known as mesomeric effect. Okay, and this mesomeric effect is also known as resonance effect. Why? Because of pi electron delocalization, it forms a resonating structures, and the resonance is also indication with this symbol. Here also I am writing same symbol. Then the mesomeric effect is also known as resonance effect, and some of the rules of resonance effect is also same. What are the some features, some important points in resonating structures? Position of nucleus will be same. The first carbon atom, second carbon atom, and third carbon atom, fourth carbon atom, carbon atom. All positions are same, and there is a difference in only position of pi electrons. Here also only pi electron position will be different. The number of pi electrons also same. Here how many number of pi electrons are there? Total 4 number of pi electrons are there. Here also 4 number of pi electrons. Like resonance, same rules will be follows. Then mesomeric effect is also known as resonance effect. Okay, and then this is the mesomeric effect. First one is definition. Pi electron displacement in conjugated system is known as the mesomeric effect. And what is conjugated system? And the second one, how we can observe the resonance and how we can observe the delocalization of pi bonds. Okay, and the third point, mesomeric effect. Next point, what is the next point is mesomeric effect is two types. What are the two types of mesomeric effect? Like inductive effect, plus m minus m, plus m minus m. The simple technique for example of plus m and minus m, which groups have lone pair of electrons, those belongs to plus m effect groups. I mean here OH, I'm writing some of examples of plus m effect groups. Here OH, oxygen have two lone pair of electrons. Here alkoxy group, here also oxygen have two lone pair of electrons. Here amine, in that case of amine also having one lone pair of electron. Here secondary amine, this is the primary amine, this is secondary amine. This is also one lone pair of electron. Nr2 tertiary amine, this is also having one lone pair of electron. Nitrogen have lone pair of electron. And simply which compounds, which groups having plus m effect, lone pair of electrons is belongs to plus m effect groups. And here we can observe one of the example. Here I am writing NH2. Okay, I'm taking one of the example. In that case of lone pair of electrons is nitrogen have one lone pair of electron, and the amine is belongs to plus m effect group. Why? Because in case of amine functional group, nitrogen have one lone pair of electron. Because of existence of one lone pair of electron, that will be plus m effect. Plus m effect means electron donor, electron donating atom. Plus m effect groups means electron donating. Because of electron donating nature, the groups having lone pair of electron is belongs to plus m effect group, and then it will be donates in this way. And this pi bond is migrated like this, and this pi bond is migrated like this, and it will be forms the one of the resonating structure. What is the resonating structure? And here NH2 plus by donating of electrons, and here one pi bond is observed, and here another pi bond, here the negative charge. Resonating structure will be observed, and then H belongs to plus m effect group. And again we can observe the minus m effect group. Minus m effect groups means electron withdrawing groups. Simply which functional groups having double bonded. For example, aldehyde, C double bond OH, carboxylic acid, C double bond OH, ketone, C double bond O, cyanide, C triple bond N. And mean which functional groups having double bonds, and those are belongs to the minus m effect groups. Why? Because minus m effect groups means electron withdrawing groups. Electron withdrawing groups. EWG means electron withdrawing groups. Plus m effect groups means electron donating groups. EDG, electron donating groups. Minus m effect are electron withdrawing groups. And this is the resonating structure for plus m effect groups. And I am writing another example for the minus m effect group. And here one double bond, and here one double bond, double bond with oxygen, and here aldehyde. and here it is a conjugated system. First of all, we can observe plus m or minus m effect. Mesomeric effect will be observed in conjugated system only. This is conjugated system, pi bond, single bond, pi bond, and alternative position of pi bonds. Okay, and then here it will be migration takes place like this. Okay, and then this pi bond is migrated towards oxygen, and that example is here bond O minus, and here H is there, and here the pi bond, here loss of pi bond, positive charge. This is the resonating structure of minus M effect groups. Okay, this is